So I'm Steven, and I will present about my work on the local biogeophysical effects of deforestation on the climate. Although you will soon notice that my presentation will be a bit more broad, as I'm still at the beginning of my research and I haven't really concluded any results yet. So I will largely focus on the project I'm involved in. It's a European project called Lama Klima, and I will talk about its goals and the goals of my research within this project. I will give a bit an overview of that, what we want to achieve, and hopefully we can have some fruitful discussions after that. So Lama Klima, it stands for the Land Management for Climate Mitigation and Adaptation. So we are trying to see what the effects of land use and land cover change and land management would be on the climate, and try to uncover this more deeply, more specifically. Also, we are explicitly trying to take into account the Paris Agreement and the Sustainable Development Goals, which links very well to this Congress as well. As you can see on the bottom of the slides, we are more specifically connecting to 5 Sustainable Development Goals, one of zero hunger, clean water and sanitation, decent work and economic growth, climate action, and the life on land. And it's a very broad consortium that we have. I myself am from the VUB, but there are a lot of other institutions related to this project as well, as you can see. And here is an overview of the objectives of our project. So the first one is to simply advance the scientific and public understanding of the coupled effects between changes in land cover and land management and the climate, and to assist in the elaboration of sustainable land-based adaptation and mitigation measures. That's the first broad goal of this project. Then the second one is to go a bit more specific and to investigate biogeophysical, biogeochemical effects of 3 key land cover land management changes. The one of and afforestation, of irrigation, and of wood harvesting. And we will be using advanced Earth system models. We will be using 3 Earth system models for that, so 3 different Earth system models. The third goal is to investigate the implications of land cover and land management changes on agriculture, water availability, biodiversity, and economic productivity. For this, also some economic modeling teams are involved. A team using Magpie and Cicero as integrated assessment models are involved in this project for this goal. And they also will help in the last objective, which is to assess the economic impact of land cover and land management changes. Of course, this is very broad, and I will not talk about all of this today, but allow me to give a bit of an overview of how our project is structured and where what should come into play. So you can see the 3 symbols in the center of the slide. I don't know if you can see my cursor. The forests are, of course, for deforestation. The saw is for wood harvesting, and the bucket with water is for irrigation. So they symbolize the 3 key land cover and land management practices we would like to investigate. And these feed into 2 work packages. The work package I'm currently involved in, and my current work is most about, is the first one, work package 1, which is the sensitivity experiments. So here we will do very extreme simulations with Earth system models to try to assess what these effects of these land cover and land management practices could be on the climate, potentially, but really going to the extreme. I will go a bit more in depth about this later. The second work package is with the economic modelers. They will do something similar, but using their models. So going very extreme, what would be the most extreme temperature they could have, and how would this impact worker productivity and things like that, yields, economic productivity. These results from these very extreme sensitivity experiments would then feed into our third work package. And this work package is meant to develop a climate emulator. And for those who don't know, an emulator is a statistical model, and it is meant to mimic actually the results, or the results the Earth system models and the economic models will give. So it should be able or learn in a statistical way to replicate the results from our Earth system models, but then without using a real Earth system model or real economic models, or being very computationally cheap. By developing such a climate emulator, which can assess the effect of land cover on climate and on economic variables, we have an easy tool which can be used in decision making and which can be used in testing. This tool will then be applied in a web interface and will be used along with stakeholders from both the active field, but also from academia, to further develop some scenarios, some future scenarios for land cover change. And these future scenarios eventually will be used to, again, be used as a basis for simulations for both the economic and the climate models. And this way, we will be able to assess the trade-offs and the synergies which exist between different land cover management practices, the sustainable development goals, and climate mitigation adaptation. A little note about the stakeholder co-design. In the Lama Klima project, we also have some webinars ongoing, which have been ongoing and which will continue to happen. I would strongly invite everyone watching or interested to also check this. I think there's a link at the beginning of the presentation, also at the end of the presentation. There will be a link to our webpage where you can also enroll for a newsletter, so you will be kept up to date about the project, its progress. And I will also post this link in the chat later on for those who would be interested. And if you know some relevant stakeholders, also please do get in touch. You would also always be interested to talk. So more specifically about what I'm working on now, as I said, the first work package of our project, so the sensitivity experiments with the Earth system models. We will do 5 different simulations of 150 years. We do very long simulations of a constant climate. So this way we avoid having to use ensemble members. And we will, each of these simulations will represent a different world, a different extreme of our world. The first one will just be the present world in a present constant climate. So without climate change, just having the 2014 climate and land cover as a constant condition for 150 years on. This will be sort of used as a benchmark to compare what the effect of the other changes would be versus the current climate we are living in. So that's the first simulation which is running. The second simulation is a global reforestation simulation. So this is a 100% forested world. It's really going extreme. There's no cities there. There's nothing except for forest, where forest can survive, however. So for example, on the poles, on the ice sheets are still there, the deserts are still there. With every land which is possible to plant forest, even which is now occupied by other land users, will be put to forest. Another simulation will be the same, but in the other way around. Instead of putting forest everywhere, we will have cropland everywhere. So these 2 simulations then sort of represent the extreme effect of afforestation and of deforestation. And by comparing these to the control one, we have a very clear signal of what the potential effect could be. Then the 4th simulation would be a simulation using extreme wood harvesting. We'll be using the wood harvesting rates of RCP 8.5, which is the most extreme ones that are available in the IPCC scenarios. And this will be also applied to the 100% forest simulation, so that it's also a very large scale application of wood harvesting, so that we have a very clear signal to distinguish. And then the last simulation will be about irrigation. This will be applied on the cropland simulation, so the 1% cropland simulation, with irrigation applied everywhere. So by comparing this simulation to the cropland simulation, we will have a very clear signal on what the extreme potential effect of irrigation could be. So these are a bit the simulations we will do. As I mentioned already, we have 3 Earth system models from three different institutions. I'm the one from the VUB, so we are running CESM. And next to these different Earth system models we apply in the different institutions, we also sort of have a different expertise. So afterwards in the analysis, we'll also sort of go deeper into our own expertise. I now have some slides dedicated to what our research goals are there. I will quickly go over each of them, but I will mainly focus on my own research questions, obviously. So the first one from LMU, the institute in Munich. They have more experience with the carbon cycle and the biogeochemical effects. So if there is a land cover or land management change, how will this affect the sequestration of carbon in land and the land sink in general? And so what they will focus on is to try to uncover these effects and reduce the uncertainty in those aspects. I don't really have anything further to say about it, so let me continue. Then the next to the biogeochemical effects of land cover changes, you also have biogeophysical effects. Let me perhaps define that very quickly. The biogeophysical effects are all the effects from a land cover or land use change, which will lead to a change in the energy balance or the water balance. So for example, with deforestation, you will get a brighter surface because the forest is relatively dark compared to grassland, and you will also have less water retention. So these are effects on the energy fluxes and the water fluxes, and these will also have an additional effect on the climate, right? And recent literature has been showing that this might be very large and is also geographically uneven. So this is a very unknown or uncertain flux, rather, that's also not integrated into any of the IPCC assessments yet and not taken into account in the Paris Agreement. So that's why this is also a very interesting focus to study. And the issue with biogeophysical effects is that you can have both local and remote effects. The local ones are the ones as defined within a grid cell. So really the effects due to the change happening in the grid cell. While remote effects are more the changes due to a change in land cover, which will lead to changes in the atmospheric circulation and will have an effect over several grid cells together. So one of the questions is, how do we separate these? And we will use the checkerboard approach, which was developed by Winkler et al., a paper in 2017, which will actually define both land cover change pixels and non-land cover change pixels, like a checkerboard. So instead of using a real 100% forested world, for example, we will actually use a checkerboard where one pixel is 100% forested. The one next to it is the control map, is the initial land use of the control climate. And the one next to it, again, is a land cover change, so a forested pixel. So I'm not sure if I'm explaining it very clearly, but this allows, by sort of having a hybrid map with two land cover maps integrated into one, allows to separate the local from the non-local effects. Let me show you an example here from Winkler's paper. So on the left, you see the total signal due to land cover change. You see that there are some pixels in there because the ones which are sort of not falling in line with the others are the ones not having occurred any land use change. So these have remained the same. Let's say all the other pixels have changed. If you can see my cursor, these are the ones that are constant land cover, while the other ones have undergone land use and land cover change. So you can see these pixels where there was no change. These are the only ones shown in a subplot G. These have had no local effects, local biogeophysical effects, because there has been no land cover change in their pixel. So if you would interpolate the effect from these pixels to all the other pixels, you could get a map which has the total non-local effects of land cover change. You can do the same for the ones which have, where land cover and land management change have occurred. This is plot E. And there you can do, again, the same. You can do an interpolation, and you get a field which is completely local biogeophysical effects. The sum of these should then also be equal to the total effect for each location. I hope this clarified somewhat. As you notice, this is not a real checkerboard. This is what Winkler called this high land use land cover change. So the majority of the pixel are land use have occurred, but we will be applying a real checkerboard. So one pixel land cover change, one not, and etc. So that's the approach how we will disentangle these effects, because these effects also have different impacts, and we will try to have an as clear distinction as possible. So then going to my own research focus, which is a local biogeophysical effect. Here we will try to focus most on the effect on climate extremes, heat wave duration, the droughts, if the land cover change has an impact on these. There's a lot of literature that's pointing to this. So it will be very interesting to analyze these results. And also with, of course, a specific focus on soil moisture, as this has been shown to be a key variable controlling this. Also look into the effects on temperature, extreme temperature, but also on extreme precipitation, of course. And we will focus on the energy balance decomposition and the water balance, how these will change, and try to understand and better understand also by comparing the different models and the different modeling assumptions to see why changes are occurring and why not, and try to limit the uncertainty we currently have about these local biogeophysical effects. Then our partners from VU Amsterdam will be trying to analyze the remote biogeophysical effects by looking into the impact of soil moisture due to the land management change on the large scale atmospheric dynamics and teleconnections, but also on feedbacks between the Rossby waves and changes in land cover changes and land management changes in geographical key regions, such as the world breadbaskets. For example, on the occurrence of heat waves and such. We will also try to contribute from the VUB side to this analysis of remote biogeophysical effects by doing some moisture tracking. We will apply the moisture tracking model of Flexport. But this is all for the future. I don't have any experience from that just yet. So I think I've given a nice overview. I thank you all for your attention. It's very nice that I got the opportunity to present our project here. And I hope next time I will present something, I will have some results this time. For more info, please go to this link. You can find a description of the project again, but also a description to the newsletter you can find there, or the webinars we've had for stakeholders to get more informed about the topics we are working on. Also, if you want to be kept up to date, there's also the Twitter, where you can follow us at CA Latest. So that's all from my side. Thank you for your attention.
Yo, thank you very much. Also perfect in time. Very nice presentation. Please, I'd like to open the floor for questions.
I have a question. Stephen, thank you very much for this. I have a technical question and then some more existential questions. But the technical question is for the tree potential or the forest potential, the 100% forest scenario. I put in the chat a link where a map was produced by Basten and all. I don't know if you know about it, the global tree restoration potential. The reason I pointed out is because I know that this methodology is also being applied for the EU in a detailed way. So maybe if you have the opportunity to talk with those authors, unless you already have, maybe, but they've gone through a lot of trouble to publish this in Science, and the Commission has recognized, the European Commission has recognized this as a nice product. So maybe if you want coherence with your project, it might be a good idea to contact them.
Thank you for pointing this out. I actually wasn't aware of it. We've been really using the most extreme possible distributions, always sort of putting all the other land covers except for the one we want to keep. For example, in the forest simulation, we have put every other land use in the pixel except for forest to 0 and just upscaled the forest distribution to 100%.
Okay.
So that was the approach we followed, very idealized, very unrealistic as well, but it's because it's also meant to serve as an input, as sort of a boundary condition for the emulator production. But this is a very interesting project, and I will definitely have a look at it if we can. It probably won't be used anymore in the setup of the simulations, but we can definitely integrate it into some analysis, or I can definitely compare it with our maps and see what we find. Thank you.
No, could be an interesting alternative to your extreme scenarios. But of course, I know you're relatively limited regarding the number of simulation runs you can doing, I suggest, yeah?
Yeah, Yeah, indeed. There's as there are Earth system models, they are fully coupled globally, so they are quite computationally expensive. So it's the amount of the extra simulations that we will be able to do, except for these, are limited. But there are still some opportunities. We have some ideas about extra simulations, so this might definitely be one of them.
All right. Okay. Any other questions at this point?
I think I have a similar one. Sorry, go ahead.
No, you go ahead. I'll type in the chat and you go ahead.
So I was wondering about the emulator that you're planning to use in the context of stakeholder or participatory modeling, right? So have you already developed parts of that, or are you building all that from scratch?
Luckily, we're not. It's not, the emulator won't be my work. It's work from ETH and CA in Berlin. But they are already working on it. Also, ETH, which is an institute in Zurich, had already developed an emulator, but within the framework of this project, it's being extended to other variables and to seasonal cycle and stuff. So it's being improved even more. And they are working on this. They are already testing, and the results seem promising. So the emulator, what they are thinking of having at the end is really, you have a certain temperature or a certain land cover and land management change, which can be applied. You have the forest, the irrigation, and the wood harvesting. We will try to put this into some kind of web tool, so some kind of site. Well, what I always imagine, I don't know if it will actually become like this, but what I always imagine is the three symbols and then some slide bars that you can really say like 100% more or less or more. And you can really play with the amount of wood harvesting, the amount of irrigation, the amount of forestation that you will have. And that then from that emulator, you could quickly get a result what the climate effect would be, the total climate effect of this combination of land cover and land management changes. So that's a bit the idea behind using this emulator, because it's so computationally cheap that we would have a really wide array of results to look at, and also a wide array to be used as a tool for stakeholders to explore what the possibilities could be of synergies and trade-offs.
Okay, sounds great. Thank you.
Okay. Maybe we have a last remark and question in the chat. So that's again from Sarah, and that's related related to biodiversity. And there is not the fear, but kind of fear that there's a too strong focus only on, yeah, basically on forest as a carbon sink, if I understood you correctly, if I understood the question correctly. Sarah, please.
I was just pointing out that it's highly complex, and I wonder how can you seriously address these questions?
It's a very nice question. It's also one of the, probably a very central question that it will be at the end of the project, once we have all these results, and we will have to try to integrate it. That's also a bit why the stakeholders are in there. It's not only stakeholders from the sectors which are involved, but also academia. So if you would be interested, please do get in touch, and you can also be added to this list of stakeholders. And at the end, we will have to see how we can indeed include this. In the scenario development, it will probably be still very difficult, as there's no real metric for biodiversity, right? So it's a scientific challenge, and I have no answer to this, but it's definitely a very nice question, and thank you for mentioning it.
Yeah, I think you can measure biodiversity, or at least you can link it somehow to ecosystem structure, ecosystem composition. And this then brings you back to what kind of forests you are looking at when you talk about afforestation, for example. Yeah, that's very, very highly interesting. Yeah.
Indeed.